Damn. Yeah, sorry for the stream. It crashed. Also don't really know why. But we're back and it finally kind of worked. But now the browser is crashing. And I probably have to rebuild it completely, which can take some time. So just gonna start it and get some energy drinks. Yeah, this is gonna take a while, guys. I'm gonna take a small break. I'm gonna be back in like 5 minutes. Okay. I'm gonna mute myself because my laptop is getting slow from all this compiling. Sorry for not being active in the stream. I just got a call and it turned out to be a longer call. Some family call, but I'm happy to be back and trying to try this out. It's been compiling for ages. Basically like an hour of compilation. It's like crazy. It's been compiling for an hour, and I need to be a bit more patient because I needed to do a fresh build because my build was crashing. I hope this fixes it. If not, then I'm gonna try whatever. Yeah, I don't know if I should talk because I think my laptop RAM is low because I'm building all these files. But yeah, just waiting for this compilation to be done. It's just like running for over an hour. This fresh Firefox build. All right, we have a fresh build. Now let's run this. All right. Interesting. Okay. It's a completely fresh build, so I need to log in on everything again. But I just want to see, like, I just want to browse a little bit. Yeah, we can just browse a bit and watch this number up here, which is going to be tracking unique bytes versus redundant bytes. Also want to know what happens if I refresh the page. Oh, okay. So there must be some assets loaded here that aren't cached very good. And we can see this because the duplication rate is going up, right? Duplicate content saved 1 megabyte, 45 out of 541 requests. Interesting data. Interesting data. Gonna go back to Wikipedia, go to another page. I guess Wikipedia is pretty efficient. I would expect it to be. I mean, it's like one of the most visited sites online. Maybe we go to Google. Let's. Well, isn't this trending on Pump right now? Nietzsche Penguin. Yeah, it's pumping right now. Where the frick is it at? 71 million? Damn. All right. And this is the page for it. Don't like it. I don't like it. uh, it seems like, yeah, whatever, bro. Whatever, bro.
Okay, what does Dex Screener say? Oh, it's a 112 million. Sheesh. Everybody's pumping into this. Great. Great. What is that? Yeah, some weird ass JavaScript being executed here. Yeah, well, I guess the Penguin does well today. Good job. I remember looking at it when it was here. But I don't really care. I don't really give a fuck. What about Nietzsche? Oh, it's pumping as well. Great. Volume 100, 1.2 amps. Great. Yeah, let's go to pump. Let's go to pump. I am ready to pump. Okay. But you can see the number up here, right? I don't know. I'm not sure if you can see it very well, but it's also not the final way of how it's gonna be displayed. But up here, there's a number that shows the redundant bytes. And we can see it's 1.3 megabytes just surfing these couple pages, giving me redundant bytes, right? So if I reload pump, it's probably gonna load some redundant things, but not enough to increase this number by much. So, But yeah, for example, our site has some terrible caching things also on it. That are really quite terrible. For example, all of these images here, right? If I reload it, bam, so many images are cached badly, right? All of these images are cached very badly. As you can see, the number increased by almost a megabyte, right? And this makes the browser super inefficient because it constantly needs to refetch things that it already knows. And this is the whole point of the thing that I thought of yesterday, right? It's like, what if we just create a cache that never expires if the content that is underneath the address hasn't changed? You know, this is what I call the forever cache, right? So right now I'm tracking all the bytes that could be loaded from cache if the cache would be smarter, right? So this is what these this is what this experiment is about. Like, how many requests are taken or are made from the browser that aren't really necessary, and they are just checking content that already that the browser already saw before, right? And as you can see, within like 5 minutes of browsing, I've already accumulated 3 megabytes of data that I never that I should never look at again from the network, because I already know this data, right? The browser already had this data. And it's 11% of static files that are fetched are redundant. 11% of static files, all right? That is a lot. That is a fuck ton, all right? And this is just within like 5 minutes of browsing the web. I've accumulated 3 megabytes of redundant data that could be saved, right? So I'm gonna look at the data specifically now by getting it from the Firefox database that we created in our Firefox fork. So I'm going to paste it in here where I have this little exploration project. And I'm just actually going to open this in the terminal also so that you guys can see it bigger. So I'm going to make my terminal really big so all of you can see what is going on. I execute the script. Okay, I need to go into the folder where it is. What was it? Nah. Yeah, cd browser log experiment, right? So actually I need to change the script now. All right. So now if I execute the script, it should crunch the data and tell me top 10 most duplicated contents. So these challenge scripts here are duplicated. The Wikipedia icon, the Wikipedia logo is duplicated, right? This is the same content. This is the same content as this one, but they are on different URLs, so they are fetched twice, right? This pump fun CGI challenge is duplicated on different URLs, but it's exactly the same. Maybe these are dynamic URLs. I would have to check this, but I don't think so because they also really look the same. Like Deck Screener and Pump.fun have like the same challenge script apparently, probably because it comes from Cloudflare or something. But as you can see, like the Wikipedia icons and logos, right? Completely duplicated, completely not necessary to fetch them twice because they have the same content hash. Okay, Google is sending like the weirdest content type that exists in the world. And as you can see, the dupe rate of JavaScript is pretty high, PNGs is high. What actually, why is it printing the ... So this can't be really. Hmm. Hmm. I need to understand this. All right, now we're there. But how exactly? Yep, now we're getting the same data as the browser, pretty sure. How does the browser calculate duplicate bytes total? Okay, so it's coming from the service. Okay, now we're getting closer to the real data. All right. Now we're getting somewhere. Now we're getting somewhere. kind of crazy how the Wikipedia logo or touch or like icon is only a kilobyte. It's kind of crazy. All of this is interesting. Oh yeah, I need to go out the window. Mhm. Mhm. Okay. So we start again collecting some data after fixing these metrics to properly track duplicated ratio. All right. So okay, we're starting to track again. And we can see there's some duplicated content. If I reload the page, this should increase once more. Seems like it's timing out. Also, I think it's not really worth it for files that are small. So yeah, need to rethink this a little bit. I mean, I don't know why it's being slow. I think it was I think it's because the content hashing on the CPU, probably. On the other hand, my CPU is pretty fast because it's an Apple CPU. I don't know. I would have to see, but wow. Shout out to Valentino. Okay, I don't know. So this guy was a pretty famous designer or something. I mean, I don't really have any Valentino pieces or anything, but shout out Valentino. All right, what other things are on the internet that we want to test? Reddit, as always. So actually, something is not going right because the ratio should go down because more static content is requested. Static files. No static files. Okay, a lot of that is cached. Understand that. So we're not tracking cache requests, which is fine, I guess. Or like requests that are intercepted from cache. So this page is kind of slow. Let's go here. So something is not right with the tracking because it definitely should update the ratio. Yeah. Damn. Pretty crazy how many requests some of these pages make. A lot of network overhead. Lots and lots of network overhead. Every time we go to our page, the ratio goes up. Let's go to pump. Where's the penguin at? 120? Crazy. I don't know about this UI element here. Don't know if it's so cool. Right. I'm supposed to believe this is real. Stupid shit. Some stupid shit. Yeah. Community has been deleted by its owners. Whatever, man. Whatever. Okay, apparently one of the issues with the metrics was that the UI wouldn't update in real time when going to a site with fresh content. So let's see if it works now. Okay, so a lot of duplicated content here, apparently. What happens if we go to a fresh site that I haven't viewed before? The metrics should go down because the amount of unique requests increases. So let's look at it. Yes. So the duplication ratio goes down because the number of unique requests increases. Now, if I reload it, it could go up because of the amount of duplicate requests. Yeah, it goes up a little bit. All right. So if I browse some more, it goes slightly up because apparently there's some duplicate content on this page that is refetched every time. Some static content. So I don't know. Let's look at some Google. Let's look at some pages we haven't looked at just to improve the metrics and improve our stats. So Instagram is very heavy with static content. But what if we refresh? All right. So of duplicate content on Instagram apparently being fetched. Let's continue to investigate and just understand how these pages cache resources, how often we encounter duplicate requests and stuff like that. All right. Some pages have good caching and they don't download any new resources, and other pages have terrible caching and download almost all of it again. All right. So this website is okay also. Since Pump posted it, it has gone down. All right. Let's look actually at the 1 hour graph. What the flip happened here? Okay. Fuck this shit. Okay. Small improvement to the metric collection. So let's just do that. And I'm gonna take a look at the data once more. So this is everything we collected. As you can see, Instagram apparently is having a lot of duplicate resources being fetched, and not small ones, may I say. But also Google Tag Manager, that makes a lot of sense. That makes total sense. Google Tag Manager is just the same shit 3,000 times. Yeah. So actually on JPEG, if we browse to Instagram, we get a 25% duplication ratio, which is insane, which is pretty insane. Let's do some more Instagramming. I feel like let's go to, I don't know, man. What's going on with Leonardo DiCaprio these days? Don't really care, but yeah, also XML. Okay. But this works a lot better now. And a duplication ratio of 10% within 10 minutes. Okay, whatever, right? It could be higher, it could be lower. We just need to test it a longer time, but then we can understand how to build this browser optimization. And the cool thing about this is no website needs to change in order for this to work. No website needs to implement anything in order for this to work. We just need to build a browser that has this optimization, and then it starts working right there, right? So we're not dependent on clients with this optimization, which is just, it's just great, right? Because we just need to build this into the browser, and no matter what the file is, if it's a JPEG, a PNG, an XML, a JavaScript file, we cache it way more efficiently because we cache it based on hashes and not based on URLs, right? And we can see that resources with max age 1200 out of, so almost all of them have max age, right? The median max age is 744 hours. All right. So that is a decent number, right? 800 hours. How much is that? It is like 800 hours, 200 hours, 240 hours is 10 days, 30 days is a month. So that's 720 hours in a month. So 744 hours is kind of like a month, right? That is a good number. So that means that the browser only refetches most files once a month. So decent number. But then when we look at the reality of things, within 5 minutes, we have 4.35 megabytes of duplicated content. And that's 13% of all of the bytes. We have 42 requests that are exactly the same but have different URLs. So they would never be fetched based on the URL, or they would never be cached based on the URL, right? That's where the duplication mostly comes from. URLs that have the same content but are refetched every time and aren't cached based on content but based on URLs, right? So that's 0.7 megabyte. And refetch is so just content that is not cached properly, right? And I am sure half of this number is Instagram. Just because Instagram apparently is not very good at it. Apparently Instagram is not very good at caching. Who knows? I could investigate it now, but I know if I open the network tab and reload this page, there are going to be 200 requests being made, and going through all of them is stupid. But we can look at some of them to figure out why they're cached so badly. So first of all, it probably has the longest URL parameters I've ever seen. Bad URL hash. There we go. There it starts. Because now it's all about like fingerprinting and shit, right? And like what the fuck are these images, man? Like what the hell is even this? I don't know. I have no clue what this is. Okay, these are these images. All right. These are these images. So just the images of those little portrait people portraits, profile images. Okay, so this is the actual Instagram pic that he posted, or thumbnail in that case. And I guess he posts mostly videos, so maybe we find one that is like an image. Okay, I guess this was an image. Yes. So how is this cached? Max age, a long time, right? Yeah. So what happens now if I refetch it? it just fetches the same shit? Please don't tell me that it does. That would be terrible. Come on, man. Like, what are these requests, man? I just want to see the images. Oh, no. Oh, no. It's a complete refetch. It's a complete refetch. Shit. This is bad. But why? Why? I guess, I know why. Because this URL can't be cached. This URL can't be cached. Because it's like crazy. I understand. They don't want you to cache it. Wow, that's so shitty of Facebook. That's so shitty of Facebook. They really don't want you to cache it. That's why they have all that crap in there. Yep. No session. No cache. That's kind of crazy. But why is that? I wonder why that is. So maybe we can investigate this a bit further, just out of curiosity. Like, is it this parameter? Okay, was not this one. Which one is it? Is it this parameter? Nope, it's not this parameter. Is it this parameter? Okay. So there it starts to make problems. Is this parameter a problem? Yep. It's interesting to just understand like what kind of things they are looking for in the URL params that blocks the image from showing completely, because then we can understand how we could potentially cache it. Okay, doesn't like that also. So apparently it's sending multiple things to fingerprint the user or to make it like a watermark, so that it can't be displayed or fetched anywhere else. It's kind of like a signature. Okay, it doesn't care about this one also. I guess they also just throw some stuff in there that is not really needed, like, or like is tracking data and not signature. So apparently there is a signature and a hash that both kind of have to do with the image potentially being loaded or not. And I bet if I change any one of these, like it's just crap is gonna come out, you know? Yeah. I don't even want to try to understand all of what this means, right? But what we can do is we could strip fragments of the query params away and then figure out, okay, with these query parameters, the image still shows, and we could cache it with these parameters and serve it every time. Or with these parameters, it doesn't cache, and we can't remove them, you know. And then we could have an algorithm that removes parts of the URL parameters in order to get there. Like we could fetch this, right? We could fetch this. We could cache this. It's just a question of like creating a mechanism that doesn't break the cache URL, but also doesn't make it so that we can't cache it. Because honestly, if we can save megabytes on Instagram, obviously we're gonna do it, you know, per user, right? Megabytes per user. So accumulated, it will be gigabytes and terabytes and eventually petabytes, right? And it's pretty crazy to me that Reddit uses so little resources. Like, yeah, fetches very small amounts of data, or all of the data is private. I don't know. So what is this image, for example? Bluey's Quest. What the hell is that? Fortnite Simpsons. Okay, Bluey's Quest. Apparently some kind of thumbnail, right? So how is this cached? Max age 7200. This means that this image will be cached and it expires after 3 hours, right? Will anything ever change about this image? No. But your browser will still try to refetch it after 3 hours, because now it's saying, hey, I don't know if this is still the latest image. Can you give it to me again? Right? So I just want to see how this behaves. If I go to this guy's profile now, posts. Oh, he likes to keep his posts hidden. If I go to the post, it's the same image, right? If I, okay, it comes from cache. Okay, nice. It's fetched twice. Nice. Comes from cache both times because it has the same URL. Yeah. And if I delete it now from cache, Reddit, what? This can't be. Can I delete it like this from cache? No, apparently not. Okay. What is the e-tag header again? I just want to understand how we could potentially, if match. Mhm.
Okay. Okay. This works. Weird. Okay. Weird. But good to know this, because then lol. This would never work. This is a meme I would buy. This is a meme I would actually buy. However, it got rugged, as you can see, and this little candle right here is probably the guy trying to rug it again. I don't know. I honestly don't know anything about trading on X and shit. Weird. All right. I don't know. I just like the post, you know. I liked the when Toli posted it. I thought it was funny. All right. We are gonna improve the metrics one more time so that we can run our little experiment for half a day or so, or for a day. And then I will also post this data that we found here on X so that we can show it, you know, show how big of an issue this could be. To solve, because now we went from talking about serving JavaScript natively in the browser, right? and we talked about curating JavaScript for the browser to create these native libraries, kind of, right? But this is a lot crazier, because now we're not just doing it for JavaScript, but we're doing it for any resource that the browser has already seen. And we're obviously not tracking private content. We are tracking publicly available content that the browser would cache anyways. Now we're caching it cross-origin based on content hashes. All right. So let's run the analysis again. This time with 2 megabytes of data. Yeah. Most of the redundant content that we saw now is really Instagram. Like a lot. As you can see here, we're fetching so many images from Instagram, right? 470. Only 230 were unique, right? So that's 50% duplication. Stupid. And on the other things, we don't have that much duplication, but fonts is actually showing up to be highly duplicated as well. And I guess JavaScript will go up as we surf the same websites. We will see more duplicated JavaScript. Same with WebP. Overall, to say duplication ratio 18% is kind of crazy. And it has to do with Instagram, right? It has to do with Instagram. Duplicated bytes 19.15 is also crazy. This can't be true. Can't really be true because that's a lot. That's like, yeah, that's 17%. That's a lot. Cross URL. Okay, but we don't have cross origin. Okay, so the max age went down significantly from a month to 2 weeks. Cross origin duplicates, only 2. Still interesting though. Still interesting that multiple websites use the same code with different URLs. Right? Very interesting. Very interesting. The same content appearing behind multiple URLs. Yeah, well, Instagram creates a new URL every time you visit an image. So it just messes with the data a lot, right? Just messes with the data a lot, which makes it difficult to track it accurately. And Reddit apparently fetches a lot of new content. If we scroll down, it's all unique new content, right? Or like most of it. That's why the metric goes down. What else can we look at? So just the starting page doesn't download unique content every time, but redundant content. Interesting. Is it every time? Yep, it's every time. Apparently, I don't. Hmm. And our website also downloads a lot of redundant content. Like if I reload, it will reload all these images. Most of them. Not all of them, but most of them. Yep. Okay. Now, Perkins Fund. It's an interesting question because I know they use the same files for multiple websites. So I know both of them, both this one and the Tracix website use similar files, particularly CDN, Tailwind, CSS. All right. So let's look at Tracix website. This is the exact same URL on a different on a different page. Okay, that was cached. All right. So these resources are cached. If I disable it, we hit it again. And it becomes duplicated. So the tracking works as expected. The tracking of duplicate data. And it will be our job to just track the amount of duplicate data that we find during browsing and then scaling this up, right? But basically, if you think about it, like Sam Altman is such a scammer, man. I don't think it's good advertisement, but whatever. If we find out that we consume around, let's say, 20 to 30 megabytes of redundant content, right? Then we can calculate per day, right? Then we can calculate, okay, how much do we consume per week? And then when we know that, we can look at how much would we consume per month and per year, and how much would 1 million people save per year. Yeah, we can tally up the numbers, and I think this is going to be great because we're going to really understand like where all the redundancy comes from and how to optimize it. And for example, with Instagram, this was exactly the thing, right? It has so many redundant images being loaded And when we looked at the data, it was like a couple of megabytes being reloaded. And this was a problem. Yeah, whatever. Like Instagram just caches really badly. And I'm sure other websites do as well. Maybe not with images, but something else. Yeah. How's UTCC doing? I don't. UTCC University. Let's go. Wikipedia. University, Universität der thailändischen Handelskammer. Let's go. Right, I'm gonna make a post on X now about this. Right, I'm not logged in on X over here. Gonna log in, make a post, and then probably end the stream. All right, I made a post. Read it, let it marinate a bit, try to understand what I'm writing there, what I'm saying there. And I will see you soon for the next hackathon stream. All right? See you soon. Bye.